Universidad Autónoma del Estado de México, Centro Universitario UAM, Atlacomulco. Victor Drives in Computing Engineers. Flexible Manufacturing System, Team 5. Garduño Romero Mario, González Yáñez Heriberto, Monroy López Miguel, Rangel Esquivel Salvador Jesús. Atlacomulco de Favela, State of Mexico. What is and flexible manufacturing systems? A flexible manufacturing systems is integrate automatic configuration of machines, tools of controls designed to manufacture different types of parts and products with minimal changes in time and cost. It's always for adaptation, mm, production, router, and volumes, watching stop operation, combination automation, CNC cells, and automated transport systems. In computing, file management systems, software that organization, stores, and management files and a computing and or network.
Main components. An FMS is made up of several elements. Transport tanks. The first is controller managed those with platform. The managed process. The second is adding and converting system, for example automatic doors or controllers responsibility for moving the parts but machine. The thing includes loading and unloading drivers, automatic ring or robotic responsibility for fire angles. Finally, a central control system or execution software means coordinating our sequence and capture data and real-time to plan, monitor product. Flexibility manifests itself primarily in two forms: router flexibility and product flexibility. Router flexibility matches what and part can to work different matching sequences depending on invalidity or propriety. The product flexibility allows ref- different refers to the manufacturer which language reconfigured whose attributes, parameters, or genre tools. The two dimensions are what's impossible to respond quickly to share in demand or to introduce a product variant with significant losses in efficiency.
Key benefits: FMEs offer reduced adaptability to change in demand, reduced downtime, better resource utilizations, and less reliance on direct labor thanks to automation and integration with manufacturing execution systems (MES). This facilitates both on-demand production and customization in small batches. The challenges are not minor. Installing and commissioning and FMS requires a high initial investment in equipment and software, as well as time in integration and testing. The interoperability between equipment from different vendors and the complexity of the control software increase the need for personnel with specialized knowledge. It is also important to plan for technological upgrades because rapid evolution can make part of the investment obsolete if it is not managed correctly. Challenges and limitations. Although powerful, FME systems involve a high initial investment, complex integration between hardware and software, the need for specialized personnel for maintenance, and the management of interoperability between vendors and protocols. Furthermore, constant technological upgrades can pose a challenge to long-term sustainability. Implementing an if-ms involves deciding of the technical elements, selecting CNC machines that cover the necessary processes, choosing handling and transport solutions, robots, AHVs, or conveyors, installing sensors and integrating them into a data network and deploying an MES or execution software that coordinates orders and captures data. It is common to simulate operations and plot with real-time vision to avoid bottlenecks and optimize resources.
Typical implementation technologies. Welcome to the future of high mix, high efficiency production. The flexible manufacturing system, or FMS and FMS, is not just a collection of machines but a few automated integrated ecosystems designed for unprecedented responsiveness. At its core are the CNC machines, which must feature automated tool and pallet changing to maximum uptime. This combined with automated guided vehicles or rail systems that manage the continuous flow of materials and tools. The entire operation is orchestrated by sophisticated software ERP handles to the high-level business functions whilst the MEA's manufacturing execution systems acts as the real-time coordinator handling job sequencing and resource allocation on the shop floor. Trends and future. Industry 4. Looking ahead, the FMS is evolving rapidly, driven by Industry 4 technologies that make the system not just flexible but truly intelligent. The power of AI. Artificial intelligence and machine learning are now optimizing more than just machines' efficiency. AI can dynamically recalculate production schedules in milliseconds if a component fails, dramatically improving overall throughput. Crucially, this intelligence power advanced productivity maintenance by analyzing vibration and acoustic patterns. The FMEAs can accurately predict a machine failure. Conclusions. And the flexible manufacturing system is a strategic imperative for any modern manufacturing requiring variety, speed of response, and constant quality in a competitive market. However, success hints on the critical factor first, deep technological integration, ensuring software and hardware system truly interprets second human capital. Investing in training a staff of manage and diagnose complex systems, not just operate machines. Some reference